writing linear equations from graphs. So we've worked on taking linear equations and creating tables and then graphing them. This is kind of like going backwards. What if we start with the graph? We have the line on the graph. Can we go backwards and figure out what the linear equation is? We can. There's really two steps we follow, and I'm going to show you those real quick right here. So we have this graph here, this blue line that has been graphed on this 4-quadrant graph. Remember, when we write linear equations, I'm going to slide this over here, it's always in the form y equals mx plus b. So we're always going to have the y equals mx plus b. And remember, we're really only solving for, if I get the b in there, the m and the b, okay? So the first thing we want to do, if we have this graphed line on the 4-quadrant grid and we want to figure out what equation is being graphed here, the first thing we're going to do is locate what's called the y-intercept, okay? Locate the y-intercept right here. So the y-intercept is, in effect, the b part of the equation. That is the y-intercept, okay? So what we're going to do is we're going to go over to this graph, and this is the easier one to find out of the two steps we need to follow. Here's our blue line. I'm kind of going over it right here in blue again, and it's being graphed. It's going up to the right, positive slope. Well, I'm going to look at the y-intercept. The y-intercept is this vertical line that's running along here. And I'm going to see right here, where does the blue line cross the green line, cross the y-intercept? Right there where I'm putting that red dot. That is the y-intercept, where our graph line intercepts, goes right across the y-axis. What does it go across at? What value, what number? It looks right at 1. Remember, 0 is there. We're going up just right over there. It's going at 1 or positive 1. So I know the b in my equation is going to be a plus 1. So this is going to be y equals something x plus 1. So we determined the y-intercept. That's pretty easy to find. You just find where the line is crossing the y-axis. The next thing we want to do is determine what's called the slope. The slope is the m, all right? It's called the slope. It is our rate of change. It's the value that's being multiplied. What we're going to do is something called rise over run, and I'm going to show that to you real quick. This is a little trickier. Takes a little practice, but this is what we do to determine the slope, or what the m is. So I'm going to locate 2 points on this blue line. I already have one. This red dot that I've put right here is a good starting point, the y-axis. I'm going to go and find another point on this blue line. I'm going to kind of follow it up right over here, where this blue line crosses perfectly across another axis right over here, where it hits another x and y spot. So like right here, it goes perfectly across 2 and 5, okay? Now, we're going to do rise over run. So when we do this, rise over run means how many from the bottom dot to the top dot, how many spaces up do we move? How many spaces up do we move? And then how many spaces over do we move? The up is the rise. The over to the right is the run. So let's count them real quick, okay? So I'll use the darker shade here. So to get the rise, it's 1, 2, 3, 4. So as I write this over here, rise over run. The rise is 4. And then the run. How many spaces over do I get till I get to that next red one? 1, 2. So rise over the run. Makes like an improper fraction. Okay. If you have an improper fraction, what do? You got to simplify it. Turn it into a whole number in this sense. 4 over 2 simplifies to really 2 over 1, which is the same as 2. So our slope, or our m in this case, is going to be 2. And we get y equals 2x plus 1 as the equation. So let's try that again with a different graph here. So we're going to take this graph. It's actually pretty similar, but I'll kind of go through the steps again. We always write this in y equals mx plus b. And all we're looking for is first the y-intercept and then the slope, okay? Now remember, the y-intercept, where does our graphed line cross the y-axis that I can draw I think, a little bit straighter. This pen is not working for me. So, where do they cross? Right there again. I think it's right at 1 again, right there. So, plus 1, because it crosses on the positive side. So, we know we're going to get a plus 1. That is the y-intercept. So, y equals something x. Just keeps moving over. Got that. Now we want the rise over run. Okay, so I have my first red dot. It looks like we can get up to another spot right there where this graphed line evenly crosses the 2, 2, and 5. And let's do the rise over the run. So how many spaces up do we move? 1, 2, 3, 4 spaces up. How many spaces over? 1, 2. So it's going to be 4 over 2 again, which again simplifies to 2 over 1, which is the same as 2. So y equals 2x plus 1 would be the equation that's being graphed here. Also, very similar to the one we did first. Now, these lines on the first two have gone up and to the right. Remember, any line that goes up and to the right, up and to the right, up and to the right, these are positive sloping lines. You'll notice the slope here, it's a positive 2x. So the line's going to go up and to the right. Check out this example. We'll do one last one. This line is going up and to the left. Now we're going to write the equation to it, but any line that goes up and to the left is going to be a negative slope. And you'll see that here real quick when we determine the equation for this one. So we're going to write this in the form y equals mx plus b. And the first thing we're going to determine, let's locate the y-intercept, okay? So we've got our graphed line. Again, I'll kind of go over that in blue. I think that helps just find the y-intercept. Green coming down here, the y-axis. And it's actually in a negative spot. It's right here on -3. So watch how I do this. That means I've got to have the negative sign. So it's actually going to be, the b is going to be a minus or a -3. Okay? So now I have y equals something x minus 3. So we've located the y-intercept. So now let's find the slope. So it looks like we've got a spot there. There's another spot where it goes perfectly across the x-axis. Right there is kind of where that -4 is. So let's do rise, rise over run. So how many spots up are we going to go? 1, 2, 3. Over. And then how many spots over are we going to go? 1, 2, 3, 4. Now check this out. Something that I didn't. When you go up, counting up on the rise, up is positive. So that was like a +3. But you'll notice this time when we did our run, we moved left. When you move left, you're moving negatively on a number line, okay? So when you move left or if you move down, you are moving negative spaces on a number line. If you move up or you move right, you're moving positive spaces on a number line. So we moved over 4 spaces to the left, so that means actually we moved a -4 spaces, which makes our slope, what we would really make out of this, we don't have to do any simplifying or anything, it's really a -3/4 slope. So the equation that we would have here is y equals negative, so I can write this neater, 3/4 x minus 3. That is the equation that has been graphed here. So just a real quick show of how you can do this. Locate the y-intercept. Remember, that's just where it crosses, your graphed line crosses the y-axis. And then the slope after that, a little bit trickier, but you're just doing the rise over the run. And simplify it if you need to. And this is writing an equation, a linear equation from a graph.